Hello, my algebra students. I'm going to give you the story on 7.1, and of course there'll be a daily incentive points for you guys to work on, some lab for you guys to work on, and so here we go. 7.1 is going to use all of our factoring that I was telling you about, so we're going to whip out the F word here and do some factoring. And I just wanted to remind you as you're working along at home that here's some problems to try, and if you need more practice you can do the left out odds, and if you need more examples you can check the book's videos. So the book also has videos that you can go and you can look at and do. So this problem, right, this story that we're going to be learning about in chapter 7 is called rational expressions, which is a fancy word. Here we're going to be looking at fractions, polynomial fractions, and so, for example, this is a polynomial fraction. In the numerator, it has a polynomial. -6 is just a polynomial, and in the denominator, this is a monomial, right? And this is a trinomial, and this trinomial has degree 2, and that monomial in the numerator has degree 1. And so here's another polynomial fraction with a monomial over a binomial. And this is also a polynomial fraction, although a rational expression, although we a lot of times just treat it as a polynomial, but it could be written over 1, and now it has a numerator and a denominator, and the denominator is a polynomial, one's just a polynomial, and so, and etc. And so here's a trinomial divided by a binomial, and here's one that has 2 variables running around in it. And so all of these are rational expressions. And so the first thing that they had us do with everything that we've kind of learned about is evaluate into it. And so now they're going to use the function notation that we learned in chapter 6, but all this is saying is to plug in that x is 0, to replace x with 0. So our f at x equals x minus 2 over x minus 1. I could write this, I like to write it with a blank, I've told you guys before, just to kind of get it going. And so we're going to have here x minus 1. And what did they tell us to put in? They told us to put in 0. So we put in 0, replace it in, and when we do the arithmetic, in the numerator we get -2, and in the denominator we get -1, and when we simplify that we get 2. And so g at 0 is equal to 2. And you probably are remembering that that this could be written as an ordered pair, but right now they're wanting to practice our function notation. So this problem will be in the back of the book, and they'll simply have 2 is what they'll have. And same here, g at -2. And if you think that this is a lot of practice for this, there's a point of why they're having us plug all these in, and so we're going to see that in a second. So if you're like, I know how to do that, why are they doing it so many times? So let's see, that's -4 over -3, and a negative divided by a negative is a positive, so this is 4/3. And then g at 2, so g of the blank equals the blank minus 2 over the blank minus 1. We're putting in 2, we're replacing our x value with 2, and this time we get 0 over 1. And when you divide 0 by 1, 0 divided by 1, you get 0. And so this is equal to 0. I'm always asked, can I just leave it here? And the answer is no, you should write it as simply as possible. You should write it as 0. And then we're going to try this next one. So we're plugging in -1, and we get -3 over -2, which is 3 over 2. And one more for us to do. Plugging in 1, I get -1 over 0. And what about that one? And you could check it on your calculator. Your calculator probably says math error. This is undefined. And so there were a lot of things that on number 2 here out of your textbook that were okay. It was okay to plug in 0, and that didn't lead to any problems. It was okay when the numerator was 0, and that didn't lead to any problems. But when the denominator of this rational expression was equal to 0, that led to some problems, made it undefined. And so the big idea that they're kind of shooting for there is that not every replacement is appropriate. So this was okay, and then it's okay, 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 but this one right here made it undefined. And so that a replacement for x is something that we would want to leave out as something we wouldn't want to replace in. And so I think that's what they're going to talk to us about next here. So on the next page of your notes, replacements that make the denominator 0 are not allowed. So that replacement would not be in the domain of the function. And they ask us, find the domain for each rational function. And when you have a rational function, those directions are really translating into find the value that would make the denominator 0, because we would like to exclude that value from the domain. And so that's kind of the thought there on those directions. And so we'll give a try on number 6. And so here we're needing to find where the denominator is 0. And we're not finding where the denominator is 0 because it's a good spot. We're finding where the denominator is 0 is because it's a bad spot and on a rational expression. And so that is the reason that we're looking for it to find it, is so because it's something that we would like to exclude. And so that's the story on there. Okay, so on number 6, I hope that I'm trying to give you a little bit of time to see if you can kind of look. So the only problem we could have with the domain is when the denominator is 0. So we want to find when it is 0. So, oops, that's not a good eraser on there, on that pencil. X minus 2 equals 0. So when we solve that, we get x equals 2. But remember, that wasn't a good value, right? And they're wanting us to talk about the domain. And the domain is all of the values that would be okay to put in. And this value actually would not be okay to put in. It wouldn't be okay to put in x is 2, because if we do, then our denominator would be 0 and it would be undefined. And so our domain is all of the values except for x is 2. And your book writes this in set notation. They say the set of x for the domain such that x is not equal to 2. And I've talked to you guys before that I will take that the idea x is not equal to 2. And so on number 10, we're going to give a try to it, and we have a function involving t that is a rational function, right? It has a denominator there. And so what we're going to do is we want to know when this denominator is equal to 0. So that's when x squared minus 25 equals 0. And there are more than one way of solving this. But I'm going to show you what the book has shown us. And that is that if it's quadratic, which means it's degree 2, you get 0 on one side, which we have, and you factor it. And so that's the strategy for solving a quadratic equation. And so x squared minus 25 factors, because it's a binomial, It either has a greatest common factor or is a difference of squares, or it could be a cube. And this one happens to be a difference of squares. And so I think to myself, this would be x times x, right? And so in my first places go the x's, and then this would be 5 times 5. And I know that on a difference of squares, it's one positive and one negative. And you can verify by multiplying that together that you get what you started with. And when I set the pieces equal to 0 and solve, I'm going to get negative 5 as a result. And I'm also going to get, when I set this piece equal to 0, I'm going to get x equals 5 as a result. But remember, this wasn't a good place. So I don't want the value to be equal to 0. So I don't want this to be 0. So I don't want this to be negative 5. I don't want this to be 5. And so your book would say the domain is the set of x such that x is not equal to negative 5, comma 5, or 5, either one of those. So all of the values are okay except for negative 5 and 5. They're not okay. And so we would want to leave them out. This is problem 5 out of your textbook, and it's asking us the same thing. I was hoping, I guess, to give you guys a few seconds to give a try to it, so I hope you're ahead of me and already have it out so that you can compare. So we want x minus 1 is not 0. When we add 1, we get x is not equal to 1. So the set of x such that x is not equal to 1. And I hope that you're doing this one too. It kind of mirrors this one, right? X squared minus 16 is not 0. And factoring it, it's a difference of squares. X plus 4 times x minus 4 is not 0. So that x plus 4 is not 0. And x minus 4 is not 0. So that when we solve this out, we have x is not negative 4. And x is not 4. And then in our fancy notation, I'm going to put it up here just because I'm out of room, the set of x such that x is not equal to negative 4 or I wrote 5 because of what was written above, or 4. And so that's kind of our story on there. So they have some problems that ask you about replacing. Those are the first problems that you'll see in the homework that we did here, the replacing problems using function notation. Then they have a bank of problems that ask you about the domain of the rational function. And directions are going to kind of be important to you guys because you're going to have to pay attention to what you have. And then the next section will ask you to either reduce or to simplify. I'm going to look and see what they put in the book. Probably simplify there is what they're writing in the book, and I think I probably put reduce out so that you know that is another word for simplifying. The way that you can simplify these, and this is the very first way that you learn to simplify a fraction, way back whenever you learned about fractions, and that was to factor the numerator, and they would say prime factor the numerator because they didn't give you anything other than a monomial. And so they would say prime factor the numerator and prime factor the denominator. And then what they asked you to do after you prime factored is you would reduce out pieces that are exactly the same because they would reduce to 1. And so when you have a binomial divided by a binomial, then it's the same story. You have to factor the numerator. And remember how a binomial factors. So a binomial would factor, that's something with two terms, by having a greatest common factor, or having a difference of squares, or being a cube. So, or it could be all three of those things, right? But that's what I'm thinking. And so I want to factor my numerator, and I'm looking at it, 12x minus 9y, and I'm thinking, does it have a common factor? I had to have a little sip of my water, and yes, it does. The common factor in the numerator is 3. 3 goes into 12, and 3 goes into 9. And so remember how I was telling you guys, you attack the smallest number, which is 9. And 9 doesn't go evenly into 12, but things that divide evenly into 9 do, like 3. And that's the only thing that goes evenly into 9 other than 1, and 1 goes into everything. So the greatest common factor is 3. So you put it in the front, and then I'm going to factor out that 3. So I'm thinking 3 times what is 12x. And so that's 4x and minus 3y. And I factored it completely because this will multiply together to give me back what I started with, and 4x minus 3y, which is my binomial, does not have a greatest common factor other than 1, is not a difference of squares, and is not a difference or a sum of cubes. And so, so I know that this is factored completely. Then in the denominator, the greatest, it's a binomial as well, and the greatest common factor is, well, they have 3 in common. They also have x in common, but they don't have a y in common. So 3x is what they have in common, and I want to make it back, so this is going to be times x, because 3x times x is 3x squared, plus, and then we're going to need a y. And then things that are exactly the same can be divided and reduced out. And what can be divided here is this monomial 3 would divide with this monomial 3. And 3 divided by 3 is 1. So this in the denominator and in the numerator is a product. 3 times this. 3 times x times this binomial. And so I can divide out the piece 3. 3 divided by 3 is 1. And so this would give me for my answer 4x minus 3y, with or without the parentheses around it, divided by x times x plus y. And in the back of the book, they're not going to write those parentheses. They're just going to write 4x minus 3y over x times x plus y. Some books will even multiply this back together, and our book does not. And I'm just as happy not multiplying it back together. So this is a good answer, and this is also a good answer. A lot of times people say, won't this x and that x reduce with one another? And the reason that they won't is because this is a subtraction. And before I could do any division there, you remember the order of operations, and the grouping symbol is the numerator of a fraction. I would have to be able to subtract this. And so before I could divide it by the x or any other piece. This is a whole piece, x plus y. It goes together. And so it really does have to be, when you've written it as a multiply, then in the order of operations, multiply and divide are on the same line, so I can do this division and then whatever else I have left. So that's kind of that story. Okay, so that was 12 out of your book, and we have a few more problems to do, and so more than I thought to do. Better get moving on it, right? Okay, so this one, I've got a trinomial divided by a trinomial, and you probably are remembering that how you factor a trinomial, that's 3 terms, is you look first for a greatest common factor, and then I unfoil, and you could do it however you like. And you can factor those pieces on your side piece of paper if you like. So I can come over here because I know that I want to factor the top, and I'm saying to myself, I have to factor, in order to reduce or to simplify, I have to factor this problem. And boy, our author, he's outdone himself on these numbers, right? And so we'll be able to figure it out because we're really clever. And so let's see here. Is there a greatest common factor? I want to factor both of these. And 9's the smallest number up there, but 9 doesn't divide evenly into 20, and 3 that goes into 9 doesn't go evenly into 20. So they only have a greatest common factor of 1 on this one. And so I'm going to try to think of the ways that you could make 20. So you could make 20 as 4x times 5x. You could also make 20 as 2x times 10x. You could also make 20 as 20x times 1x. And do you guys think I have them all? And so that's me thinking about what would make the first work as I move on to FOIL. And now I'm going to be thinking what would make the last work. 1 times 34 and 2 times 17. And that's going to be it there. And so I'm trying to look for something. I know the signs are the same. Signs, same. And that's what that tells me. And this one says, yeah, they're both negative. And so, and that means we're going to add up to 9 in the center. And so, and that's 93. Oh my gosh. 93 in the center. I was thinking there's not going to be anything, folks, that's going to make 9 in the center. When I added up, that was way too little, and it was a typo. It was a hopo, maybe, that I was thinking that I didn't have anything that bad. Let me think about greatest common factor again. 93 is no longer the smallest number up there. 20 is the smallest number up there. And the things that go evenly into 20 are 4 and 5 and 10, because 20 doesn't go into 93. But none of those things go into 93 or 34. 2 goes into 34, but doesn't go into 93. So nothing goes into all of them. And whoops. I don't know, maybe I caught that there was 9 here. Okay, so I'm going to try to make that 93, and I'm thinking, well, what would be the most likely? What would I give a try to make 93? And I always like to, I don't know why, I'm going to start off here with the 4x and the 5x. And I know they're both negative. And I wish I would have written up there higher, and now I've learned my lesson. And I'm thinking that if I use 34, that's going to be way bigger than 93. I mean, remember, it was going to add up to 93. And so if I put 34 here, 34 times 5 is already bigger than 93. And if I put 34 here, then 4 times 34 is already bigger than 93. So I know it can't be that. So I'm thinking about 17 and 2. And so I was kind of going to fish out, well, what if I put the 17 there? So I'm going to just see what 4 times 17 is real quick. And it's 68 is what it is. So if I put the 17 there, I'll get a 68, which is not too close to the 93, not close enough anyway, because I'm only going to get 2 times 5, which is 10 from the inside. So I'm thinking that maybe I had better put the 17 multiplying with the 5, and maybe let's try that. So when I do that, I'm going to get 17 times 5, which is 85x, negative 85x, that's from the inside there. And from the outside, I'm getting minus 8x, and I'm hoping that those will add together to give 93. So 85 plus 8, and I know they're both negative, so that's negative 93. So hot diggity dog, it wasn't as bad as I thought. So this was me factoring the numerator. And so I'm going to write that right here for my numerator is 4x minus 17 times 5x minus 2 divided by, and then I'm going to come over on my scratch piece of paper and I'm going to factor that trinomial and I'm going to put it right there, and then I'm going to see what they have in common. So the ways that you could make 4 are x times 4x and also 2x times 2x, but I can't help myself and notice that if it's going to reduce with what I have over there already, it probably has 4x in it. So I'm going to try that. Okay, this had 34. So that's either 1 and 34 or 2 and 17. And I'm kind of feeling like this again maybe has something to do with what I have. So I'm going to try this, and if it doesn't work, try, right? And if it doesn't work, now I know the signs are 1 positive and 1 negative. And right at this moment, I don't know which one is which, but I'm going to give a try to it. So just kind of matching. If something was going to cancel, it'd have to be, from what I have possible, would have to be minus 17 here. And this would have to be plus 2 if it was going to cancel, just to what was left over, right? The 17 and the 2 go together. One has to be positive, one has to be negative. Kind of used what I had over here just to see if it'll work. And so when I do the outer, I get negative 17x. When I do the inner, I get positive 8x. And I'm hoping that when I put those together, that I'll get negative 9x. And indeed I do. So that little guess worked out perfectly. So I'm going to put that over here, x plus 2, it doesn't matter order, and 4x minus 17. And then I'm going to divide pieces that are exactly the same. So 4x minus 17 divided by 4x minus 17. When I divide this and this, I get 1. And that leaves over, so I'm going to divide those out, and then that leaves over, left over, 5x minus 2 over x plus 2. And so we reduced that rational expression. We're going to try the next one here. I'm going to make a hard line here. And I'm going to, this is number 11. I think that that's how I did do it, yet I'm remembering back when I made the notes, which has been quite a long time ago, that I see that there's even and there's odds here. And I think that it was because I was giving you guys a few seconds to try that. So there was your few seconds to try that. And so how you reduce is you factor, and what I want to factor is the numerator, x squared minus 16, and also I want to factor the denominator, 6x plus 24. And I factor them separately, and then I put it back together is what I do. And you can factor them in your head. So I've got it over here on my side piece of paper, my scratch paper or whatever have you. I always give you enough room so that you don't have to, that you could write it out like I have done. But you could factor that in your head. This is a binomial. It does not have a greatest common factor other than 1, but I notice it's my friend, the difference of squares. And so this is x and x, right? So I notice it's a difference of squares, x and x. Remember, a difference of squares has a plus and a minus, and 4 and 4. So that's how that numerator factored. So in the numerator, x plus 4, x minus 4. There are as many people that will look at that and go right to there, and that's wonderful. Divided by, then the denominator. And this does have a greatest common factor of 6. So always on every problem you think greatest common factor, and the greatest common factor is 6. So I'm going to put that over here. That won't factor further, that binomial, because it does not have a greatest common factor. It's not a difference of squares, that's an add. That's also not a perfect square, so lots of things wrong with it, and it's not a cube. This will not factor further. It's not a greatest common factor, difference of squares, or a cube, and neither is this. This would factor further if this was x squared, but it's not x squared, so it won't factor further. So we have underneath here 6 times x plus 4. And we don't have any monomials that will cancel because there's no monomial up in the numerator. So the monomial 6 will not reduce with anything. But x plus 4 divided by x plus 4 is 1. So when you divide these, you get 1, and leaves you with x minus 4 divided by 6. So a lot of people put a line through them like that. And however you want to go is all fine with me. And what makes these more difficult is harder to factor, right? That's the only thing that makes them more difficult. And so you just have to remember how to go. So this 39, the numerator, has 4 terms. And so I'm over here on my side piece of paper, and I'm going to give a factor, right, to that numerator, x to the third plus 3x squared minus 4x minus 12. So that's my first thought, is to factor that numerator. And how you factor things that have 4 terms is you first figure out, do they have a greatest common factor? So things with 4 terms, greatest common factor. So do they have something in common for all 4? And the answer in this case is only 1. They only have 1 in common, so we don't have to do anything. And then you try grouping if it has 4 terms. And so now I notice it's in descending order, and that makes it nicer when you're grouping. If you can write it in descending order, do so. And so I'm going to group those first two, and now that's a binomial, and I'm going to ask myself, does that binomial factor? And how do you factor a binomial? By starting with, does it have a greatest common factor? And the answer is yes. It has what in common? My husband brought me some water, and I hope I wasn't gulping it too loudly, but boy, it's really nice. So this is x squared is the common factor, x plus 3. And then the last, remember you bring down this sign, and what the last two have in common is, I'm going to group those together, and they're a binomial as well, and you start off with greatest common factor on everything, and they have 4 in common. So the minus 4, so I'm actually going to pull out a minus 4, and so this has to be x. A common boo-boo is to put minus right there and say it's done. And you get 2 chances on knowing that that's wrong. These have to be the same, and if they're not, go make sure that you didn't make a mistake. So since they're not, that makes me suspect that I might have made a mistake. And then the other way that I would know that I made a mistake is if I multiplied that together. So when you multiply this together, remember you factored out a negative, so that gives you that, but a negative times a negative should be a positive. So this should have been a positive because I wanted the result to be negative. Now they are the same. And so what you do is you factor out the binomial that these have in common. And they have the x plus 3 in common. So you put it in the front. And then you can divide it off, right? So this is going to be x squared minus 4 for inside my next binomial here. If I multiply that together using FOIL, if I FOIL this together, it will give me what I started with here. It might be out of order, but you could reorder it if you liked. And so now I want to make sure these pieces are done. So this is done. It's a binomial that doesn't have a greatest common factor, a difference of squares, or a cube. Is this done? I hope that you're saying, no, it's a difference of squares. And so this is our friend, the difference of squares, right? And so it's not all done, and it factors as x and x, a plus and a minus, and to make 4 is 2 and 2, and so the x plus 3 comes down. So this numerator that we had factored in to these 3 pieces that now you can check, and all 3 pieces are done. They don't have greatest common factor, they're not difference of squares, and so it's all done. So this is our numerator. Now I would like to factor my denominator. So here I am over here factoring that denominator, x squared plus x minus 6. And it is a trinomial that does not have a greatest common factor. So I'm thinking make the first work, x times x. I'm trying to make the last work. It could be 1 times 6, or it could be what times what? It could be 2 times 3, because it's going to subtract to give 1 there in the center. So this says subtract. So I know that this has to be a minus and this has to be the plus. So this is x plus 3, x minus 2. So we'll put that in the denominator. That's done. That's done, right? It won't factor further. And now we're going to reduce what will reduce. And so I notice that the x plus 3 will divide with the x plus 3, and when I divide them, I get 1. And the x minus 2 will divide with the x minus 2, coincidentally here, and when I divide them, I get 1. And so what's left over is just x plus 2 in the numerator, and you have 1 in the denominator, and you don't have to write it if you have 1 in the denominator. And so there you have that. Okay, so this is getting to be quite a long video. It probably is going to go into 2 parts. And oh my gosh, I'm just going to stop it here and do part 2, have control over part 2 myself. So we're continuing on 7.1. 7.1 was a little longer than normal. I think that I had quite a lot of examples there just to really make sure that everyone's kind of on page with how that's going. 48 is asking us to simplify, and so we're going to give a try to simplifying here. I look at that numerator there, and in order to simplify something, you need to factor the numerator and factor the denominator. And when I look at it, I'm thinking, does that factor? And I hope that you guys are saying out there in YouTube land, it's out of order, right? Put it in order. And if I put it in order, that'd be negative y plus 1. And then now I want to factor out the negative leader. And so now I could make my political joke and have all the politicians of the United States writing me letters about, if your leader is negative, you should factor him out, right? And so I'm going to factor out a negative 1. And so here comes a negative 1 out of here. So this is going to be x minus y. So that's how I'm going to leave the numerator. And then the denominator, I'm going to factor it as well. So factor. I don't know if factor is as good as pizza, but it's pretty good, right? And so I notice that this is, my friend, the difference of squares. It doesn't have a greatest common factor, and it's a binomial. And so how I factor the difference of squares is, this is y times y, a plus and a minus, and 1 times 1. And this is done. So I'm going to put these in where I have them. So this was my numerator, negative 1 times y minus 1. And this is my denominator, y plus 1, y minus 1. And then I'm going to reduce anything that is exactly the same. Because when you divide out two pieces that are exactly the same, you get 1. So y minus 1 divided by y minus 1 is 1. And so when I reduce that, I get 1. And then negative 1 times 1 is negative 1 over y plus 1. In the back of the book, it might be that they take this negative that's here, because it's just a monomial, and move that negative to the front. So this would be also a good answer, negative of 1 over y plus 1. So that's also a good answer to write it like that. They're both good. So there's our answers. The next thing we're going to look at is the difference quotient. And for you people, my friends that are going on to pre-calculus, you're going to look at the difference quotient quite a bit. And so you're going to be seeing that difference quotient. I'm going to look up my notes here and see how I have. So I we'll do there's two difference quotients, and we're going to try both of them. And they're function notation. And so we're going to try this here with negative 3x as our function, and then here's our what we're going to be replacing in. So we're going to start off with part A. So I'm going to write f of the blank just so that you guys can kind of imagine, minus 3 times the blank here. And so when I do here at part A, this is f at x minus f at a divided by x minus a. So this says go to the function called f and put in x. So when I put in x, and then it wants to know what's the output. And when I put that in, that is negative 3x. So that's what I'm going to replace for how I drew this circle around there, right? And I put that in. So this is negative 3x, and then this is subtract, and then we're going to put in f at a, and so this whole piece, f at a. So when I put in a, I'm going to have negative 3a. So subtract negative 3a divided by x minus a. And you know how I am about when you're replacing. I'm usually all about, hey, put those parentheses in when you replaced. And I agree, I should put parentheses right here when I replace. Because what I replaced in was that, and what I replaced in was that. And so what this gives me, when I put this together, that double negative makes a positive. So it becomes negative 3x plus 3a divided by x minus a. And then you should reduce if you can. And how you reduce is you factor the numerator, or simplify, and you factor the denominator. So if I factor the numerator, it has a common factor of 3. And since my leader, the negative 3x, is negative, I'm going to factor out a negative 3. So this becomes, now be careful with your sign here, negative 3 times x is negative 3x. A negative times a negative will make a positive. I already have the 3, so all I need is an a. Then the denominator is x minus a, and I can't factor that. So I'm just going to write x minus a, and in fact I'm going to put parentheses around it to tell myself I thought I should factor it, and so I want to treat this like one piece, and I wasn't able to factor it. And do you guys agree with me that the x minus a's would reduce out? So x minus a divided by x minus a is 1. So I simply get here negative 3. Then the other difference quotient with a little bit different notation, and they're both really powerful. And you're going to be looking at them in pre-calculus and also in calculus. In calculus they'll tell you, hey, this is the slope, is what it is. And so, but right now we're working on the algebra of working with this. And so I'm going to erase in here. So when we do this one, f at x plus h minus f at x over h. And so this says, and I'm going to go ahead and put in my parentheses here. I wish I would have done that on that other one over there. Okay, so this says go to the function called f, this whole piece, right, that I'm going to be doing, and plug in for the input x plus h. So I'm going to put that right here, x plus h. And I'm going to make this a little bit bigger, and so that I have a little more room, and I'm going to put in x plus h. So this piece that I'm going to have here is going to be negative 3 times x plus h. And then this one says go to the function called f and put in x. So I'm going to erase out here, and I'm going to put in x. So I get negative 3x. And then I'm just going to clean it all up. So here, negative 3 times x is negative 3x. Negative 3 times h is minus 3h. And these parentheses here that I had weren't really needed because there's nothing in front here. And then this is a negative times a negative is a positive, so that's positive 3x all over h. And then minus 3x plus 3x is 0. And so I have minus 3h over h. So those made 0 when I combine like terms. And then h divided by h is minus 3. And then we did a lovely job on that. So that really was 2 problems almost. And so on the next page, I have one for you to do. And it's a homework problem, 55, to give a try to. And so you could pause the video right now and then do it. I hope that you do. I hope that you pause the video on all of the odds and give a try to them and then do them together with me. So this is part A. I'm going to write this like I did before. So f at x minus f at a over x minus a. And when we put in x, we get, we're going to be filling in there, right? We get 4x. When we put in a, we get 4a. And I'm talking quieter as if like you're working on it yourself. And so when I'm subtracting those, right, I want to factor this. I don't have a lot of room, so I'm not going to write it without the parentheses. But the parentheses are really not necessary there since I had a monomial. When you have a binomial, they will be necessary there. And fortunately, we have one here so that you can see that. And so this is going to be 4 times x minus a when I factor that numerator over x minus a. And the x minus a's cancel with one another, and give 4 as our answer. And we want to try that with part B. And so this is f at x plus h minus f at x over h. So the parentheses over h. So we're going to be plugging in x plus h. And I'm going to distribute this right now. This is going to be, when I put it in here, 4x plus 4h. And then I'm going to plug in x. It's kind of my working zone, right? X. And so I'm going to get minus 4x. So minus 4x. And you can see what's going to happen. 4x plus 4h minus 4x. The 4x minus the 4x is 0. So I get 4h divided by h. And the h divided by h is 1, right? And gives 4. Now we're going to try a binomial with the same thing. And so this is 62, and I think that is not still the end of 7.1. Oh my goodness, 7.1 is a monster. And so I'll have to make sure that the daily incentive point is really short on it. So here we are on part A, f at x minus f at a divided by x minus a, and I'm going to put my replacer in here, right? So I know that that's up in the other zone, but so I'm going to put in x, and so we're going to have here so when I put in x, I get x squared minus 3. And then I'm going to come and I'm going to put in a. And I get a squared minus 3. And then now this parentheses were really necessary because I need to distribute that negative. So this is going to be x squared minus 3. A negative times a positive is a negative a squared. A negative times a negative is a positive 3a divided by x minus a. The 3's are 0, so I get x squared minus a squared, and this will only reduce if you could factor the numerator and the denominator. And the numerator is a difference of squares. And so it will factor, because this is a difference of squares, DOS, it'll factor as x, and plus and a minus, and an a, all divided by, and the denominator won't factor, x minus a. But now you notice, oh, they'll reduce with one another, x minus a divided by x minus a. So this gives us x plus a as our answer. Then we'll try B and see how we do. So B I'll put over here. B is the other difference quotient. There's 2 of them, and you're going to learn that they're equivalent to one another. And so far they've been looking equivalent to one another, and that might not be the case here because this doesn't even have an A going on. So it's not going to end up with an A. But when you take Math 1, you'll learn that they're both finding the slope. So when I put in here x plus h, so right now, you know how they always tell you, that's what you're going to see next. And this book is really good about foreshadowing what you're going to have. I'm going to make that bigger, and I'm going to make this bigger. I don't know why I've gotten so particular on size there. So x plus h. So what I'm going to have here in here is x plus h squared minus 3. And then what I'm going to have in here, when I just replace it with x, is just x squared minus 3. And now I've got to figure out what's inside here. And the most common mistake people make is just saying that this is going to be x squared plus h squared. It's not. How you have to square a binomial is by using a formula or by writing it twice and using FOIL. So I like to write it twice and use FOIL. So when I do, I get x squared. Then I get an xh. On the inside, I get another one, and I'm going to write it xh. And then I get plus h squared. So really, I did not get just x squared plus h squared. I get this lovely middle term as well. 1xh plus 1xh, which is 2xh. So inside of here, this was just this right here, minus 3, right? And so what I'm going to have is this, which I just worked here. So x squared plus 2xh plus x squared minus 3. And then, so that ends there, right? And I'm going to drop those parentheses because they don't have anything to multiply through here. But this one does. A minus times a positive is a negative x squared. A negative times a negative is a positive 3 over h. And then the x squared goes away, makes 0 with this x squared, right? X squared minus x squared is 0. Minus 3 plus 3 is 0, and leaves 2xh. Oh, I miswrote that. This was h squared. This should have been h squared. I'm sorry, and so that was h squared. It was h squared, and for some reason I wrote it as an x, and then started to think, wait a minute, what's going on here? So I have 2xh plus h squared left in the numerator over h, and I'd like to reduce that, and it will only reduce if the numerator will factor. You could write it in order. You could write h squared first, or it doesn't matter. Either way, it has a common factor of h, and I get 2x plus h divided by h, and h is going to divide with h, and I'm going to get here 2x plus h as my answer. And yeah, I know they're not the same on this. And so anyway, so that was the end of that one. Boy, that was a long problem. I wonder if problem 61 in your book is similar, if you could give a try to it. Maybe it is. And that was double problem doing. Okay. Then they have here the graph of two rational functions are given in figure 3 and 4. Use the graph to find the following. So they ask us to find g at 6. And so this is the graph for f, and this is the graph for g. See how it says y equals g at x, y equals f at x. And they also tell us the equation that goes with f and the equation that goes with g. And we might need that. I don't know if we need the equation. We might just be able to use the ordered pairs. So we were able to find these kind of things either by a graph or by an ordered pair or by an equation. And actually, they've given us all three here because we have the graph, we have some ordered pairs, certainly not all ordered pairs, but some, and the equation. So we're going to, for number 66, we're going to go to G. So over here to G, we're going to go where x is 6, and they're asking us what is the y value, and the y value is 1. So we've kind of practiced this before. This is saying x is 6, y is what? And so we just went and found it. It's 1. So G at 6 is 1. So this is problem 65b. It says f at -1. So we want to come over here and look at the f graph. And at -1, so we're going to go over to -1, the x value is -1, the y value is -4. And you can see that that would work even if you use the equation. If you plugged right into this equation, -1, -1, 4 divided by -1 would be -4. And same here, you can check it. Okay, so this is G at 6 is what I want to find first. And good news is I found that here in part 66A, and that was equal to 1. So this is now F at 1, and then I'm going to go to up here and F at 1 to the F, make sure you're on F, and the X is 1, the output is 4. So this is 4. And make a note to myself, more room. And G at -2, I don't think I found that. Oh, excuse me, F at -2, and I don't think I found that anywhere. So, but I can come up here and look, is equal to -2. So this is G at -2. So coincidentally, the X value and the Y value are the same, right? And so now I'm going to find G at -2. So I come over here to where G is -2, so there's X being -2, and the output is -3. So this is -3. And then this one, 65C, is a little bit tricky because it has F at 0. And if you're looking at this graph, right, F at 0, 0 is right here in the center. And if I look up, ooh, it doesn't go there. And if I think about the equation, 4 divided by 0, wait a minute, right? 4 divided by 0, that's undefined. Okay, so I'm hoping that it's no. So stop saying you're hoping is what I'm going to say to myself. And yes, this is the last problem. It really is. And at 67, it's probably a problem I would have assigned for homework, so you can give yourself a few minutes and see if you can do it. It says the following rational function, so pause if you're going to do it. The following rational function is one we mentioned in the introduction to this chapter. The quantity W at X is the weight in pounds of a person after X weeks of dieting. Use the function to fill in the table. Then compare your results with the graph in the chapter introduction. Okay, so they're asking me to find W at 0. And I'm going to put that work right down here. So W at blank is 80 times 2 times that blank plus 15 over whatever X is plus 6. And we're going to be putting in 0. And then you could certainly put this in your calculator, okay? And someone sent me an email and said, if you lift your calculator up just a little bit, we can see what buttons you pushed in. And I thought, oh man, no, that's really smart. And so I'm going to push my fraction key here, and I want 80 in the numerator, and I want parentheses 2, and I'm going to just put it just like I have it, and plus 15 into parentheses, and then I want to go down, and I'm going to put it in here 0, and then plus 6. And then my calculator will give me, and it gave me 200. And let's see, I can scoot everything over a bit, right? A little bit. So this is 200. I don't think that when I write that 200 here that you're going to be able to see it that well. And I wrote it as boldly as I could. I don't know if I have a better pen on me. I don't really. 200. Okay. Then they're asking me to find out 1. And so I'm just going to be filling in, right, for 1. I was going to write it again, and now I'm thinking, don't be silly. Put in 1, put in 1, put in 1, right? And then let's see what we get when we put in 1. That eraser doesn't work. And so we're going to try that and see how we go. Now I can edit on my calculator. I'm going to go back. And I'm going to put, instead of 0, I'm going to, I don't know what side I have to be on that. I was on the wrong side. 1. And so for the delete. And I'm going to go back here and I'm going to put in 1 right there. So delete and 1, and then hit equals, and my calculator gives me 194.2. And they didn't tell me where to round, but this is somebody's weight. So I'm going to round to the 10th, and if I round to the 10th, that's going to be 0.3 because the next number is an 8. So 194.3. And then I'm going to put in 4. So instead of 1, I'm going to put 4, and my plot is just to go backwards here and just use my calculator to do it. And so I don't really want to have to put it all the way in again. So 4 here. And so I get 184. And I'm going to put in 12. So by the same token, 12. Then I'm going to have some lunch. And I get 173.3. And when I round appropriately, I'm saying the 10th is where I'm saying. It didn't say where to round, so I've decided to round to the 10th. My scale in my bathroom gives me to the 10th. And this is the weight. So I'm thinking that sounds good. And then 24. Okay, so 168. Okay, so is that all they asked us to do, was to fill in that table with the different values? Yeah, it is.